Welcome. You're watching First Principles AI, where we prioritize depth over trends and understanding over hype. If you're a professional trying to move from AI demos into real systems, misunderstandings like this cause real world problems, such as hallucinations, unreliable answers, and systems that look great in demo but fall apart in production. So, in this video, I want to explain how a RAG system actually works from first principles without tools, without buzzwords, and without hype. So let's get started. To really understand this, we need to step back and look at it through the lens of first principles. Retrieval Augmented Generation or RAG is everywhere right now. But here's the thing, a huge number of RAG projects are failing, and most of the time it's not because of the model is bad. It's because of a very basic misunderstanding of what RAG actually is. So today we are going to cut through the hype and build a clear mental model from the ground up. So you can see what's really happening under the hood. The big myth. You have probably heard the pitch 100 times. You just give model the access to your data and it does everything. It sounds powerful, right? Almost magical. Like you just plug it and it suddenly the model knows all of your company's internal knowledge. But this simple appealing idea is exactly where the confusion begins. So first we'll learn about what RAG is not. So before we talk more about RAGs, we have to be very clear what it is not. Let's bust a few common myths. RAG does not give a model persistent memory. So RAG does not make any model smarter, and RAG does not improve the ability to reason, and it absolutely does not guarantee the correct answers. The model you start with is the exact model you end with. Okay, with those myths out of the way, let's talk about what's actually going on. So, what RAG really is? Here's a simple, maybe even boring truth. A RAG system is just a two-step process. First, it retrieves chunks of text that seems relevant to your question. Then, it injects those chunks directly into your prompt, sent to the language model. That's it. No magic, just a process. So this is how RAG works and what a RAG is. So coming to the analogy, this analogy makes everything click. Imagine you have an assistant who can read incredibly fast but have zero long-term memory. You don't train this person for months. Instead, every time you ask a question, you run into a filling cabinet, grab the three most relevant pages, hand them over, and say, based on these pages, answer my question. That's RAG. So the RAG has three core components. So how does this assistant find the right pages so quickly? Under the hood, a RAG system has three components: indexing, retrieval, and generation. Let's walk through each one. So coming to the indexing, this happens before any user even shows up. You take your documents, split them into smaller chunks, convert each chunk of list numbers called embedding, and store those numbers in a vector database so they can be searched efficiently. And I cannot stress this enough. Everything depends on this step. So how you check your documents, which embedding model you use, how clean and structured the data is. So if you get this wrong, the entire system is built on sand. No language model, no matter how powerful, can save you. So coming to the next component, retrieval. So next, when a user asks a question, the system does the same thing again. It turns the questions into numbers. Then it performs a mathematically similar search, like finding the document chunks whose embeddings are closest to the question's embedding. Notice what's happening here. This is called pattern matching, like not reasoning, not understanding. So think of it like a search bar in your internal company Wikipedia. You type in a few words, it returns pages that look relevant, but does it actually check whether those pages answer your question? No, that's still your job. The retriever in the RAG system works the same exact way. So coming to the next component and the final one, it's generation. The retriever text strings are stuffed very literally into the model's prompt. So the model sees that the text and treats it as a ground truth. It doesn't verify it and it doesn't know where it came from and it just assumes it's correct. And the generates answer based on it. And then it brings us most important takeaway of this entire video. RAG is not intelligence. It's just a mechanical process. Search plus context injection. That's it. It's clever plumbing. And understanding that distinction changes everything. Let's go to end flow. Let's put it all together. Here's the full journey of a single question. 1. The user asks the question. 2. The question is converted into numbers. And then 3. A vector search retrieves the closest matching chunks. And 4. Those chunks are copy pasted into a prompt. And last step, the model generates an answer based only on that prompt. At no point does the model independently thinks or validate anything. It doesn't check the answers, the correctness or anything. It just only generates the model's output based on the retrieved information. So why demos fail? And this explains something important. Why does so many RAG systems look incredible in demos but fall apart in real usage? Because if the chunking is bad, you feed nonsense. See, if chunking is bad, you feed nonsense, nonsensical, and non-semantical words. If retrieval pulls junk, you feed junk. If the documents are outdated or wrong, you feed garbage. And we all know how the story ends. Garbage in and garbage out. So where RAG works and where it doesn't. So where should we actually use RAG? RAG shines in retrieval heavy tasks, searching internal documentation, answering HR or policy questions, building Copilot for structural knowledge. But the moment that you need is real reasoning, connecting the ideas across documents, resolving contradictions, or answering vague questions. RAG struggles. Why? Because it's a retrieval tool, not a reasoning engine. It's only gives answers on retrieving, not it can't give answers by reasoning. And if you are building these systems, you never work really ends. Like indexing needs versioning, retrieval quality needs monitoring, data changes requires re-indexing. This is a continuous MLOps and data engineering effect. In practice, success with RAG almost never comes with a fancier model. It comes from better chunking, better indexing, and better evaluation. It's an infrastructure problem first and a model problem second. And coming to the summary, let's summarize the first principles. One, RAG doesn't give model memory or intelligence. It retrieves text and injects into context. And system quality depends on almost entirely on the data prep and the retrieval accuracy. That's the whole game. So, which leads to an interesting question. If RAG is just an search plus context, then what do we really mean when we talk to about AI agents? What's fundamentally different between a RAG and an AI agent? That's exactly what we'll break down in the next video. Thanks for watching. If you want to build long-term leverage by understanding the why behind the how, you will find more content like here in on First Principles AI. Thank you. Thank you for watching.